Hey guys, today we're going to be talking about solving systems of equations by graphing. A system of equation is when you have two or more equations. In Algebra 1, we're only going to be doing two equations containing two or more unknowns. So we're going to have two variables, like an x and a y. So two equations and have two different variables. The solution to a system is an ordered pair that makes both equations true. And the solution is found where the two lines intersect. So for example, that is where my solution would be located, the point at which the two lines cross. On example 1, it says determine the number of solutions for each of the graphs below. So on this first graph right here, we know the solution is where the two lines intersect. So these two lines cross, one time, so I know that we'll have one solution. So what happens if I have two lines that end up being the same exact line, which means that one line ends up falling on top of the other one? Well, I know they're touching here, and here, and here, and here, and I can continue to do that forever and ever. So there's no way I can count the total number of solutions, so that's why on that one we say they have infinite solutions. Okay, on this next graph we have two lines that are parallel. Well, we know parallel lines never touch. Well, if the solution is where two lines intersect, and parallel lines will never intersect, that means that we will have no solution. Okay, so on this next one, it says determine how many solutions each system has. If it has exactly one solution, name it. Well, on this first graph, I have these two lines, and I can see that they cross, so I know it's going to have that one solution right here at that intersection. In this intersection, I have to name that coordinate, and they intersect at the point 3, because it goes to the right 3, and then down 1, so negative 1. On this next graph, I see my two lines. They do intersect, so this one will have one solution at this point right here. And as a coordinate, it goes to the right twice, so that x value is 2, and it does not move up or down any, so it's 2, 0 is its solution. On that last graph, they are parallel, so I know they will never intersect, so that one has no solution. Tells me the graph of the equation y equals 1/2 x minus 4 is given below. So this is 1/2 x minus 4. It's telling me to graph this guy right here on the grid and find the solution. So I know the number by itself is my y-intercept, so on the y-axis I'm going to go put a point at 1. I know my slope is the number in front of the x, which is negative 2. I like it as a fraction, so I'm going to put it over 1. Which tells me from this y-intercept, I need to go negative 2, which is down, excuse me, down to right 1, put a new point. Do it again, down 2, right 1, down 2, right 1. Once you have your points drawn, you're going to take a straight edge and line your points up. Okay, so once you have it graphed, you should be able to see where those two lines intersect at this point right here. So we're going to name that. I know that point is to the right 2, so that's 2, and then it goes down 3, so 2, negative 3 is my answer. That is the solution to those two equations, because that is the point at which those two lines cross each other. Okay, so this time we have to graph both of them. So, lucky us, both of these are y equals equations, which means I don't have to do any math. I can just throw it on my graph. The number by itself is my y-intercept, so on the y-axis, I'm going to go put a dot at 1. My slope is 3 over 5, which means from this y-intercept, I'm going to go up 3, right 5, and put a dot. Once I have my points, I'm going to use a straight edge and draw a line that goes clear across. So that's this guy. Okay, y equals -2. That's a weird one because the x is missing. So since it's a y equals equation, I'm going to write Hoy. Because Hoy reminds me that y equals equations are horizontal lines. So I'm going to have to draw a horizontal line. But first, I'm going to go to the y-axis and put a dot at -2. Once I have my point on y at -2, I'm going to draw a horizontal line through that. So now I have both of mine graphed. So now I'm going to find the solution, the point at which they cross, which is here. So as a coordinate, it's back 5, which is -5, down 2, which is -2. So the solution to those two equations is the point -5, -2. Okay, unfortunately, B is going to be a little bit more work because if you look at this equation right here, y is not by itself, so I'm going to have to do that first. So I'm going to have to get rid of those -2x's by adding 2x's to both sides. So that's going to leave me with y equals -5 plus 2x. So now that y is by itself, I'm going to take my y-intercept, which is -5, and go put that on the y-axis, so down 5. My slope is 2. I'm going to put it over 1. So my slope is telling me to rise 2, run 1, so up 2, right 1. And I'm going to repeat that, up 2, right 1. Once I have my points, I'm going to use my straight edge and draw a line that goes through those points. So now I can move on to my next equation. This one does not have y by itself either, so to get rid of that x, I'm going to take away an x from both sides. So that's going to give me y equals 1 minus x. So now that y is by itself, I can graph it. The number right here, this number by itself is my y-intercept. So on the y-axis, I'm going to go to 1 and put a point. Our slope is the number that comes in front of x, so I just see a negative, so remember that's the same as a -1, so I'm going to make that a fraction, -1 over 1, which means from my y-intercept, since it's -1, I'm going to go down 1, right 1, down 1, right 1. And repeat that. Once you have your points drawn, use your straight edge to draw a line clear across your graph. And then we can find our solution, the point at which they cross, which is right here. So that point moves 2 to the right, so that's a +2, and down 1, so that's -1. So the solution to those two equations is at the point 2, -1. All right, so if I look at my first equation, I notice y is not by itself, so that's what I'm going to want to do first. I'm going to take away an x from both sides. My -3y drops down, and I'm going to have 6 minus x on the other. Next step is to get rid of that -3, and I'm going to do that by dividing by -3 on both sides. My y drops down. So notice on top, this is a number, these are x's. You have to treat them completely separate. So first, 6 divided by a -3 is a -2. Remember, this is the same thing as a -1. So if I take a -1 and I divide it by a -3, it's going to be a +1/3, and my x drops down. So now that y is by itself, I can graph it. My y-intercept is this -2. So on my y-intercept, go down 2 and put a point. My slope is a +1/3, so from here I'm going to rise 1, go to the right 3. So up 1, right 1, 2, 3. Repeat that, up 1, right 3. Once you have your points, you can draw your line using a straight edge. So moving on to that next equation, this one is not y equals either, so I'm going to have to solve for y. I'm going to take away an x from both sides. My negative 3y drops down. And on the other side, I have 3 minus x. So next, to get rid of that negative 3, I'm going to divide both sides by negative 3. My y drops down. So remember, these are different, so I have to treat them separately. So first, 3 divided by a negative 3 is a negative 1. This is the same thing as a negative 1x. So I'm going to take a negative 1 and divide it by a negative 3. That's going to give me a positive 1/3, and the x drops down. Now that y is by itself, I can graph it. So my y-intercept is this negative 1. Oops, my fault. So notice, guys, this was a negative 3. I forgot my negative sign here. It should have said negative 3 minus x. Let me fix that real quick. So when I took a negative 3 divided by a negative 3, that actually would have been a positive 1. My fault. So my y-intercept is a positive 1. My slope is a 1/3, so I'm still going to go up 1, right 3. Repeat that, up 1, right 3. Once you have your points, you can draw your line using a straight edge. That was kind of bad. Let me try that again. All right, so now that they're both graphed, you should notice that these two lines are parallel. And you should have noticed from the equation, notice this slope has a positive 1/3. This slope has a positive 1 slope. We know that lines that have the same slope are parallel, which means they will never intersect. So my answer on this one is no solution. Okay, last one, lucky us, y is by itself. So I can go ahead and straight up graph this guy. My y-intercept is the number by itself, which is negative 1. So I'm going to go down 1 on the y-axis and put my point. My slope is 2, so it's the same as 2 over 1, which tells me from here I need to go up 2, right 1, up 2, right 1. Once you have your points, you can use your straight edge to draw your line. Unfortunately, this next equation does not have y by itself, so let's work at doing that. First, I'm going to take away those 6x's from both sides. My negative 3y falls down, and on the other side, I'm going to have 3 minus 6x. Next, to get rid of that negative 3, I'm going to divide both sides by negative 3. My y falls down. So remember, these are different. This is a number, these are x's, so treat it separately. First, 3 divided by negative 3. 3 divided by a negative 3 is a negative 1. Next, negative 6x. So I need to take negative 6 divided by a negative 3. That's going to give me a positive 2, and my x falls down. Now I can graph this. So my y-intercept is this negative 1, so I'm going to go down 1 and put a point. My slope is this 2, so I like it as a fraction, so 2 over 1, which is going to tell me from here I need to go up 2 over 1. You should be noticing that it's landing exactly on the line that's already there. So we have the same exact equation here. So if we have two lines and they land on top of each other, I know they can touch everywhere. So I know that all of these could be solutions. I can't name all the possible solutions, so that's when we call it infinite solutions. All right, later guys.